Hello, today we are going to be talking about different types of rocks and the rock cycle. So we've talked about these before, but there are three main kinds of rocks. There are igneous rocks that form from cooled magma or lava, sedimentary rocks that form from weathered pieces of other rock that have been compressed into those layers through a process called lithification, and metamorphic rocks, which form from any kind of rock, igneous, sedimentary, or metamorphic, going through a change caused by heat, pressure, or sometimes some chemically active fluids. So you're probably familiar, at least a little bit, with the rock cycle, how rocks can change from one kind to another. If we think about starting with magma, when magma cools and hardens, it becomes igneous rock. An igneous rock can weather and erode, and those little pieces can be compacted to form a sedimentary rock. Or an igneous rock could feel some heat and pressure and become a metamorphic rock. A metamorphic rock could also weather and erode to become sedimentary, or sedimentary could go through heat and pressure to become metamorphic, and any of them can melt to go back to being magma. We call it a rock cycle because there is a circular path through it, but there are lots of different paths you can take through this cycle. Almost any rock can turn into almost any other kind of rock in a single step. An igneous rock can be weathered and transported to become sediments that get compacted and pressed down through that process of lithification to become sedimentary. Or igneous can go through heat and pressure to become metamorphic, or igneous could melt again to become magma. Metamorphic can melt to become magma, can be weathered and eroded to become sediments, and then get lithified to become sedimentary. And metamorphic can also become a secondary metamorphic. Metamorphic rock can feel heat and pressure and change again. Sedimentary rock can be uplifted and weathered and become sediments that then get compacted again to become a different kind of sedimentary rock. It can go through heat and pressure to become metamorphic, and it can also melt to become magma again. And igneous could melt. Any of these different paths are possible, and so there are going to be a lot of arrows that cut across or go multiple directions. So let's go a little bit deeper into each of the kinds of rocks, starting with igneous. These are the most abundant rocks on Earth. Most of the rocks on Earth are igneous rocks. There are two kinds of igneous, and then we categorize them based on two different things. So the two kinds of igneous are intrusive or plutonic and extrusive or volcanic. We will mostly use intrusive and extrusive in this class. Intrusive means it forms underground from cooling magma. When it is underground, it's called magma. When it is above ground, it is lava. So when magma cools underground, you get an intrusive igneous rock like granite, diorite, or gabbro. When lava spews from a volcano or erupts out of the crust and then cools and hardens, you get an extrusive rock like obsidian, andesite, basalt, scoria, or pumice. Within intrusive or extrusive, we then classify igneous rocks based on their texture and composition. The texture is how big are the crystals in this rock. Remember, crystals and minerals can form when magma or lava cools and hardens. So the texture is how big are those crystals, how big are those minerals, and how are they arranged. And this has a lot to do with how quickly does the lava or magma cool. A fine-grained igneous rock has very, very small crystals in it, or very, very small minerals. It cooled quickly, so this is typically an intrusive rock, like basalt. Coarse-grained is bigger minerals or bigger crystals that you can see more clearly, like your granite countertops. Typically coarse-grained is an extrusive, but there are always going to be exceptions like granite, which is intrusive. Porphyritic is a combination of both. This is sometimes intrusive, sometimes extrusive, some fine grains, some coarse grains. different size minerals within the rock. So porphyritic is some kind of combination that sometimes can look like a chocolate chip cookie. Glassy is like obsidian, where you get volcanic glass. This is an extrusive rock, and it is a very fast cooling. There is no time for any crystals or minerals to form within the rock. You just get this glassy obsidian, for example. And lastly, vesicular is an extrusive texture where really what's the identifying feature is not so much the minerals, but the air bubbles. If there are a lot of air bubbles when the rock is cooling and hardening, they will still be there. So if you've ever gotten a pedicure and had your foot scrubbed with a pumice stone, that was volcanic rock, and that would be a vesicular extrusive igneous rock. Secondly, we can classify igneous rocks based on what the composition is. What chemicals are present in the magma or lava will determine what minerals form. Remember, different chemical combinations make different minerals. And the amount of different kinds of minerals can determine what the name of the rock is. So if you are 50% one mineral and 50% another, you will have a different name than if you are 25, 25, 25, 20. Depending on how many different minerals and how big of a chunk those minerals are, that will determine the name of this igneous rock. Next, we have sedimentary rock, and sedimentary rocks are only 5 to 10% of all of the rocks on Earth, but they are a large majority of the visible rocks. 75% of the rocks that we can see on the surface of Earth are sedimentary. Most of the rocks underground are igneous. And sedimentary rocks are broken into two different groups, detrital and chemical. Detrital sedimentary rocks form when sediments or little pieces of weather rocks get smashed together and compressed. So this is based on how big the particles are. Sandstone, would you believe, is when a bunch of sand gets squeezed together until it is a solid rock. Conglomerate has these big rounded particles. It looks almost like a bunch of pebbles have been glued together. Breccia is similar to conglomerate, but instead of big rounded rocks, it is big jagged particles that make up breccia. Siltstone is made of dirt and particles, dirt size, that have been compressed. Shale is about the same size as sand, but it is more of a flat particle, not so much rounded like sand is. So shale is a much flatter. But detrital forms from pieces of other rocks that have been compressed together. A chemical sedimentary rock forms from minerals that have been dissolved in water or from organic sources. For example, limestone is made mostly of calcium carbonate, which is what makes the shells of aquatic animals, or waste from aquatic animals. So limestone is mostly made of shells or waste from aquatic animals that have been compressed together. You find a lot of fossils from sea creatures in limestone. Rock salt is what you get when you've got a salt flat. You've got a salty body of water and the water evaporates and you get a rock that is mostly salt because everything else has evaporated. Coal is a special kind of sedimentary rock that forms when swamps specifically get buried and compressed over time. And as they get squeezed, it becomes a different type of coal, but each one is a swamp that is slowly being lithified. So lithification is just the fancy science name for sediments getting compacted and compressed and squished together until they form sedimentary rocks. So coal, an example of a chemical sedimentary rock, starts as a swamp environment and you get peat, which is some partially altered plant material. You can burn it for energy, but it is very smoky and does not give a lot of energy. As it gets compacted, it becomes what we call lignite, and there's a lot of lignite here in Texas. And this is kind of a soft brown coal that is moderately compacted, gives a moderate amount of energy, and is still fairly smoky. If it gets squeezed even more, it becomes bituminous, which is a soft black coal that is used for a lot of power generation and industry, and it is pretty good at energy. So all of those, peat, lignite, and bituminous, are chemical sedimentary rocks. The next level, or the last stage of coal, anthracite, is actually a metamorphic rock. So any kind of rock can go through metamorphism. Sedimentary, igneous, or metamorphic can feel heat or pressure and change into a different kind of rock. It can change the size, the shape, the color, the way the atoms are arranged, all sorts of different things about the rock. And it can be a high grade or low grade change. It can be a very big change, lots of properties of the rock change, or it can barely change at all. There are three types of metamorphism. Burial metamorphism, where rocks are getting buried by other things on top. This is a very low grade change. The burial doesn't necessarily squeeze a whole lot out, and it is caused by pressure. Contact metamorphism, which we a little bit saw when we had some igneous intrusions when we were looking at relative dating. Contact metamorphism is another low grade change, not a huge amount of change, caused by heat, typically from nearby lava or magma. And the third type of metamorphism is a regional metamorphism. This is a high grade change that does both heat and pressure. This typically happens where there is major tectonic movement happening, where there's a volcano or an earthquake or something like that. You'll get regional metamorphism. So we can look at whether the change was high grade or low grade, how big of a change was it. And for metamorphic rocks, we can also classify them as either non-foliated or foliated. Foliation is when the minerals line up because of the pressure. The pressure or heat that is changing these rocks squeeze it, and all of the minerals line up and look like stripes. So foliation is when you've got minerals that look kind of striped or in parallel layers, like in slate, schist, or gneiss. Non-foliated rocks, the minerals aren't aligned. They don't look striped. So marble, quartzite, these are grains are randomly arranged, not so much looking striped. So slate is a low-grade foliated metamorphic rock that comes from shale. Schist is a high-grade foliated metamorphic rock that comes from slate. Gneiss is a high-grade foliated rock that comes from granite. Marble is a medium grade, somewhere in the middle, non-foliated rock that comes from limestone. And anthracite, which is the cleanest kind of coal, the most effective kind of coal, is a high-grade metamorphic rock, non-foliated, that comes from bituminous. So there is your crash course on the rock cycle and the different types of rocks. We're going to be doing some practice next with how to identify different rocks and what are all of the different routes you can take through that rock cycle. I'll see you later.